Hello and welcome to another video of our workshop number 8, workshop number 8, various methods of solid meshing. Basically, we're going to show you how to mesh various ways using Patron. What we're going to do is we're going to create a new database. We're going to call it LUG. You go ahead and click OK. We're going to have our dev database, and the initial settings are going to be the same, just based on model 10, Nastran code, structural analysis. We're going to click OK. Now we're going to import a file, and it's important to note that it's not an IGS file, it's a parasolid file, and it's called LUG. So I'm going to apply that right away. And a window pops up immediately showing the transmit files import summary. I'm just going to click OK. And we have it now. We have our file. And what we're going to do is we're just going to go into ISO view 2 just to make it a little better. And we're going to create a group right now. So that's our ISO view. And we're going to create a group. And our group, we're going to modify a group. Sorry about that. We're going to modify the default group. We're going to go into rename in the default group, and we're going to call it hex 8. Oh, sorry, that didn't type in. We're going to call it hex 8. I'm going to click OK. Once our hex 8 group's created, we're just going to enter, click OK. And we're going to have to create points for plane creation. So we're going to create points from extract. So we're going to go, first of all, into geometry, create points, extract, and at this point what we're going to do is the parametric position has to be set to 0.5, and we have to click uncheck auto execute. We're going to have to shift click 3 edges, so I'm just going to choose the 2 edges that make up the outer radius of the solid and the edge of the back edges. And we're going to just click on that right away. So I'm going to go to curve list and go shift click, and shift click. So at this point I have 3 solids created. It's selected, and I'm just going to go ahead apply. The points have been created, so at this point what I want to do is increase the point size. So I'm going to go in home and change our point size to 9. Our next step was to create the solid points, the planes. So we just go right into plane, create plane, and 3 points, and we choose points at this order. For this plane, the first plane, we're gonna go and select the 2 planes created at the top, and actually the 3 points we created at the very beginning. And for the second plane, we're gonna use these 2 points for reference, and this 2 points for reference, and this point to establish it. Now we're going to use these planes we've created as break planes. So we're going to go into edit, solid, and break, and we're going to go ahead and just check off auto execute. And what we're going to do is we're going to select our solid 1, and for the break point we have to move to plane. My mistake. Again, we're going to select solid 1 as the solid, and we're not going to auto execute, and I'm just going to break it with plane 1. I'm just going to go ahead and click apply, and and we're just going to click yes for all. Now we're going to do the same thing with plane number 1. Just hit apply again. Now that our solid has been broken, we're going to go into group, and we're going to create a group, and we're going to enter group TET4 under the group name. So we're just naming it after different meshes. I'm going to click apply, then cancel, and now I'm going to go back to geometry, and we're going to transform solid, and our method's going to be a translation. So our direction vector is going to be 0. So we're going to call it Z, -10, and Z. And we're going to select all 4 solids in a group hexate and click apply. So we're going to just select solids 4 through 7. I'm not going to auto-execute, I'm just going to click it. I'm going to apply. Now we have our translation, and we have 2 of them, which we have group hexate at the top and group TET4 at the bottom. And now we're going to create another group called group TET10, and so it's basically going to be the same. So we're going to go to group, create TET10. I'm going to click apply. The group's been created. Now we're going to go back to geometry, and solid translate, and the direction of course is going to change. So our X direction is going to be 15, and it's just going to be 1 instance again. And what we're going to do is we're going to select solids 4 through 7 again. Just apply, and there's a new creation. That's our TET10 group, this is our TET4 group, and there's our Hex 8 group. So right now we're just going to post a group, and we're going to post group Hex 8 only. So we can apply, and this is our group Hex 8. This is the front view, but right now what I want is an ISO 3 view, I'm sorry. So this is the view we want right now. And what we're going to do next is we're going to create a few points for breaking planes, and we're just going to go to geometry, create point from extract. Make sure this is at 0.5, and we're going to select a few solids. So we're going to select this. We're going to shift select this, 4 curves, 1, 2, 3. Okay, so I'm going to redo it. I'm not quite sure. So we're going to shift select this, 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 and this, and we're gonna hit also the lower portion there. We're gonna hit apply, and we're gonna see the points start to pop up there. So this is exactly what we want. We want those points to create more breaking planes, and what we're gonna do is we're gonna create another point at the center of the arc. And so we're gonna create point, and we're going to create an arc center. So what we're going to do is we're going to select 2 portions that make up so we already have that point, and it's been created. So our next step would be create more breaking planes. So we're going to create planes. We're going to create plane 3 points, and the points we're going to select are as follows. For the first plane, we're going to select on either side and the newest point, which is at the bottom. We're just going to hit apply after that, and that creates our first plane. The next plane we're going to create is going to be using this point, that point, and finally the center point of the arc. Hit apply, and we create another plane. Having those planes is important because now we're going to break the solids again, and it's quite simple. So we're going to break the solids with the planes as we did with 4. So we're going to go edit, solid, break, and the solid list is going to be the entire model, and we're going to break it with this plane first, and we're going to hit apply and then yes for all. Now that we've created sort of another break, we're going to go ahead and create a new point as a projection. So what we're going to do is we're going to select the point where the plane is, and we're going to select the edge normal to the hole. And we're going to go right into it right now. So we're going to create our point list. It's going to be here and up there. So here and up there. So we're going to create, not auto execute, our point list is going to be here, and the curve list is going to be up here. Hit apply, and that creates a new point that we didn't have before. And then we're going to create a plane with 3 points. So we create a plane, 3 points, and our points in order are going to be here, here, and finally on the opposite edge. My mistake. Our points are going to be here, here, and here. That creates a plane right there. My assumption was wrong, and my planes should be like this. Our next step will be to use this plane to break a solid. So the solid we're going to break is solid number 19, which is here. And what we're going to try to do, actually it's solid number 16, and the plane we're going to use is this plane, and we're just going to hit apply, and we're going to go yes for all. So this is the plane that's been broken, and now we're going to delete solids in planes. So we're going to geometry, we're going to go into our geometry, delete solids, and we're going to delete solids 4 and 5 just because they're no longer useful for us. Going to apply it, and now we're going to delete planes and we're going to delete all the planes we have. 1 through 5. That deletes our planes. And now we're going to delete the size of our point markers, so they aren't in our way. And that's what we're left with right now. What we're going to do now is refit the solids. So we go into geometry and we edit, and we're going to edit the solid and just click on refit. Our settings are going to be 1 and the refit parameters right here, and we're going to be sure to check delete original solids, and we're going to select solids 16 through 18 and 20 and 21. Just going to click apply. So now we're missing a solid. Now that we have our solids created, the next step is to translate the geometry. So we're going to go to transform solid, and we're not going to translate it, I'm sorry, we're going to mirror it, and we're going to select 3 points for the plane, and we want to select points that are in the figure. So when we come here, we're going to select the 3-point option, and we're going to select here, here, and here. The evaluation has already been made. We're gonna uncheck auto execute, and for solid lists, we're just gonna create all the solids. So I'm just gonna grab them. I made a slight mistake. Selected them for a different purpose. So I'm going to use this 3 points. The 3 points have been selected, and now for the solid list is where I select everything. Just apply, and that's the mirror. Now we have our initial model in terms of just solids, so we can analyze it correctly. Our next step, we're going to create a group called Hex 20. And we're gonna click apply and cancel. The group's been created. Under geometry, we're gonna transform mirror, and we're gonna translate. We're gonna translate that geometry into 1500. So we just have to edit the Y. We're gonna select all solids and click apply. It's been posted. Now we're going to go to group, post, and we're going to select all, click apply, then cancel, and we're going to specify front view. We're going to click fit view, which is already there, so we don't really have to click it. And we're going to reduce the size of the point markers and undisplay the solid labels. So this is what we should have right now. Our next step is to create a coordinate system with 3 points, and it's going to be a cylindrical system. And the 3 points we're going to select are on the origin, the point on axis 3, and the point on plane 1, 2, 3. So we're gonna go and we're gonna go to the hex 8 model, which is our first model. I'm gonna zoom in. I'm gonna increase the size of the points and the origin. And select this point. Now that our coordinate system has been created, we're going to post group hex 8. And as you see, it's the only one now, so it's posted correctly. And what we want to do now is go to meshing, and we're going to create a mesh on the solid. And our type of mesh is going to be a hex mesh, iso mesh, and hex 8. And we're going to select all the solids. Our global length is going to be 0.5, and we're going to select the entire geometry and apply it. So that's our mesh. At the points, you can see it. Now we're going to post group hex 20. And applying it, what we're going to do is do the same, just cancel this, go to find an element and create a mesh called hex 20. And we're going to apply it to the hex 20 geometry. And we can see that it's a quite finer mesh. So for comparison purposes, I'm going to post both hex 8 and hex 20. And we can see the different kinds of meshing used in both. For simpler purposes, I'm just going to go ahead and post all groups now. So now they're all posted. And the next thing is we're going to select group tet 4, which is our bottom left. And I'm going to go to find an elements, create a mesh, and it's going to be a tet mesh for the tet 4. And I'm just going to go ahead and the input list, make it this group, the tet 4. Global length of 0.5. And we're going to click on assembly parameters and match parasolid faces. And I'm going to select all the tet 4 solids again. Close that and apply it. And that's the analysis, the meshing. Now we're going to do the same, but with a tet 10. And again, switching that and switching the input list to the tet 10 group. I'm going to apply it. And it's going to eliminate the tet 4, but it doesn't matter because we already have the analysis for the other one. We're going to verify the element boundaries. We're going to apply it. So these are the free edges we're going to analyze. Then we're going to go to equivalence into all intolerance cube and just click apply. Those are the nodes that we can see in the hex 4. Now we're gonna transport the coordinates. So transform under geometry. We're gonna transform the coordinates, and we're gonna translate them in the direction 1500. Now we're gonna select coordinate group 1. And we're going to create apply. Now we're going to do the same, but for 0 and -10, and then we're going to hit apply again. And we're going to do the same for the next one. So they all have their individual coordinates now. Our next step is going to be to create a spatial field. So we're going to enter the name sin pressure for hex 8 for field name, and so we're going to select coordinate 1 for coordinate system. And under scalar function, we're going to enter sine r of sine r of apostrophe t. So we're going to create that variable. Close, and then we're going to click apply. Now we have to do that for hex 20, of course with its own coordinate system, and just click apply. And then we're going to do that for tet 4 with its own coordinate system again. We're going to click apply, and the same for tet 10, again selecting its coordinate system and clicking apply afterwards, creating the 4 fields we need. So now we're going to start creating loads and boundary conditions. First of all, we're going to create pressure among an element uniform, and we're going to call the pressure hex 8. That's where we're going to apply it. And our input data, the pressure is going to be 1,000 units. And under pressure, your input and we're going to select just a hex 8, I'm sorry. And under load BC scale factor, we're going to select under load BC scale factor, we're going to select 1,000. I'm going to click OK. We're going to apply, select the application region, and the 4 faces indicated the pressure is going to be along the inside of the circle. So it's 1, 2, 3, and 4 faces. Go ahead and click add, OK, and then we're going to go and click apply. So that's the pressure being applied on red. Now we're going to create loads and battery constraints for the rest of it. So for the other, we're going to go ahead and create it again. So we're going to create a new one called hex 20, input data hex 20, OK, and we're going to go on and just do it for the hex 20. And for the application region, I'm going to go and select the same 4 faces. Oh god. Going to click OK, and then we're going to select apply, and again the pressure has been created, and we're just going to do the same for the TET meshes. So TET 4, input data, you go TET 4, 1000 again, and for the application region it's a little different for the TET, so it's not as divided, so it's just going to be 2 solid sections selected. Click OK and apply, and the pressure has been applied. And we're going to do the same for the final one. So it's a TET 10, input data TET 10, OK, and the application region again, it's just 2 faces. OK and apply, and the pressure is on. Now we're gonna select the constraints. So what we're gonna do is we're gonna go to create, displacement, nodal, and we're gonna call it just constraint. We're gonna show a linear deformation, so what we want is the input data, the translation, we want it at 0 for all sections, and the application region, we're going to start selecting geometric entities. So I'm going to click on surface or face, and I'm just going to start selecting the bottom faces, or this side faces, if you may. And this is going to allow us to demonstrate. I'm just going to go ahead and click apply. So you can see it's been constrained and pressurized. Now we're just going to create our materials. So we go to properties, isotropic, create our isotropic net manual input. So we're going to call it aluminum because that's the material this piece is made up, and the elastic modulus is 10 times e to the 6th. The Poisson ratio is 0.3. I'm going to click OK and just apply. So it's created, and in properties again, we're going to create (3D). Create a 3D solid, and for property name set, we're just going to select solid. And in input properties, we're going to create the material property name aluminum. Just going to give it there. Click OK. And for application region, we're just going to select all solids. Add and OK. Then we're going to hit apply. So these are all the characteristics of our solids now and our material. We're supposed to check the load cases, but that's been done already through our recording of this video. Now we're gonna run the analysis. We're gonna analyze a full run, and our translation parameters are check. Our solution is linear static, so we're just gonna go and hit apply. And our black box is doing the trick right now with the analysis. The analysis has been made, and now we're gonna access our results by attaching the XDB file. I'm gonna select our result file, and it's gonna be lug file. Now we're gonna click OK and apply. The results have been attached, and now we're gonna go to results, create, and deformation, and we're gonna see we're gonna select displacements translational, and we're not gonna show undeformed, but we will show the display attributes. We're not gonna show the undeformed or the title. And we're gonna hit apply so you can see the deformation on the pieces due to the pressure. We're not seeing this again because of the meshing problem we have with our sales agreement, but as you can see, the top part, which is the hex meshing, has been done correctly, so we've proven the point. And now we're gonna create our fringe, and we're gonna select stress tensor, which is our best option. We're just gonna make sure it's in von Mises and click apply. And now that is the analysis we want for our point. And this is it for this edition of our workshops. Thank you very much.